Whole genome sequencing unlocks our genetic makeup, and with it, the promise of new treatments and cures. But how can we best protect our most personal data while still realizing its enormous medical potential? Welcome to Ethically Sound, a podcast of the Presidential Commission for the Study of Bioethical Issues. I'm Hillary Wicai Viers. Today we're speaking with Anita Allen, Henry R. Silverman Professor of Law and Professor of Philosophy at the University of Pennsylvania, and a member of the Bioethics Commission. But first up, patient advocate and mother of three, Retta Beery, shares her story of how whole genome sequencing changed her life.
My name is Retta Beery. My husband Joe and I have three amazing children, Zach and our twins Noah and Alexis. Noah and Alexis were born on August 16, 1996. They were colicky for 15 months. They threw up multiple times a day, and they weren't reaching their developmental milestones. They had seizures, urine refluxing up into kidneys, and many other challenges. We were quickly thrown into a new world filled with medical specialists, hospitals, emergency rooms, therapists, and lots of unknowns. Noah and Alexis were diagnosed with cerebral palsy when they were close to 2 years old, based on evidence found on an MRI. After 4 years of research, I found an article that led us to a different diagnosis and the drug L-DOPA. We went from a life of wheelchairs and feeding tubes, never knowing if our kids would live independently, to gymnastics, dance, soccer, basketball, and running. In 2009, Alexis started struggling for breath, and we almost lost her on several occasions. We had 18 months of paramedics in our house trying to get Alexis breathing, 7 emergency room visits, multiple specialists, lots of testing, and daily inhalations of racemic epinephrine just to keep her vocal cords open. In 2010, we had Noah and Alexis's whole genome sequenced. At 14 years of age, we finally had black and white evidence of Noah and Alexis's neurologic disorder. We discovered that Noah and Alexis had a genetic mutation in their sepiapterin reductase gene. This evidence showed us that not only did Noah and Alexis have a dopamine deficiency, but they also had a serotonin deficiency. We were able to add an additional therapy to their L-DOPA, and Alexis started breathing again. Alexis was back to running and living a full life. Whole genome sequencing literally saved her life.
Genetic testing has become commonplace in research and medical care. For a small fee, you can even mail in a sample of your DNA and get a report back on what diseases for which you might be at risk. Whole genome sequencing, which maps a person's entire genetic makeup, is dropping in price and could soon become as widespread as other routine medical tests. Already, it is helping doctors diagnose and treat rare diseases, as in the case of the Beery twins. With access to genomic data from large numbers of people, scientists will be able to personalize treatments and even potentially develop cures for common diseases such as cancer, diabetes, and Alzheimer's. But medical progress will stall unless individuals feel secure enough about sharing their whole genome data with healthcare providers and researchers. Because of the immense amount of information that can be gleaned from your whole genome, there are serious concerns about how to preserve privacy and protect against misuse of data. As the Bioethics Commission reviewed the privacy and data access issues that arise from whole genome sequencing, it found these fears are not without warrant. There is a great degree of variation in what protections states afford to their citizens regarding the collection and use of genetic data. Only about half the states in the U.S., for example, offer protections against someone taking and testing your DNA sample without your knowledge. In many states, someone could legally pick up your discarded coffee cup and send a sample of your saliva to a laboratory for testing to learn about your health or ancestry. What's more, protections vary depending on whether you get your whole genome sequenced at the doctor's office or in the researcher's lab. In its report, Privacy and Progress in Whole Genome Sequencing, the Bioethics Commission put forth a series of recommendations aimed at protecting individual privacy, ensuring confidentiality, and preventing unauthorized genetic testing. Chief among the recommendations is that federal and state governments ensure a consistent set of privacy protections for genetic information, regardless of how that information was obtained. You can download Privacy in Progress and all the Commission's reports at bioethics.gov. Here to talk with us about the Commission's report Privacy in Progress is Dr. Anita Allen. Dr. Allen is a professor of law and philosophy at the University of Pennsylvania and a member of the Bioethics Commission. Welcome, Dr. Allen. Thanks for being here. Today, you can get your full genome sequenced for about $1,000. Should we all have it done?
Well, it's a matter of choice whether or not you should have your genome sequenced. People have to decide for themselves whether they want to know the kind of information that's going to be gathered. There's a lot to think about when you're considering getting your genome sequenced. For example, you should know that the presence of a gene doesn't necessarily mean that you're going to develop a particular disease or condition with which that gene is related. There are just a very few genes that might be uncovered in a genetic test that relate to a specific disease. For example, Huntington's disease. But for the most part, people will get information about predispositions, tendencies that will help them to better make health decisions, but that won't actually diagnose any particular condition. Not only is it possible to get your whole genome sequenced today for about $1,000, you can also today for about $100 send off a tube full of saliva to companies like 23andMe and have your ancestry revealed to you based on DNA analysis. And everyone agrees that people should have the right to decide what happens to their genetic data in terms of with whom it's shared. And we just got to make sure we have the right policies and laws in place, both in the private sector and in the public sector, and in the research and medical sector, and in the direct-to-consumer sectors that will, safeguard what could be potentially, I don't want to say dangerous, but potentially sensitive and unwanted uses of information that could occur.
Now, since the Bioethics Commission issued its recommendations, what steps have been taken to protect individual privacy in whole genome sequencing?
The Commission's report recommended regulatory clarity and that there be a great respect for the fact that more data being created would mean a greater need for looking at issues around how do we access information, how do we secure it, and how do we share it responsibly. The Department of Health and Human Services implemented regulatory rule changes that increase the privacy and security of everyone's genomic data. The rule changes clarified genetic information's really being a part of what we mean by quote-unquote health information, and revised HIPAA's privacy rule to increase privacy protections for genetic information.
How did the diverse backgrounds and expertise of the Commission members inform the recommendations in this report?
As you know, Hillary, the Commission has been incredibly diversely constituted. I think our Commission is, in fact, the most diverse commission of any of the presidents thus far. We have members who are male and female, black and white, Christian, Jewish, Muslim backgrounds, people from India, Iran ancestry, people from government, civilian life, doctors, lawyers, members of the clergy. So all of this diversity was brought to bear on the question of what kinds of privacy and data protection concerns are raised by whole genome sequencing. And I think that this wide variety of backgrounds meant that some of the questions asked were not just the obvious ones about how data can be protected, but also deep understandings and different understandings of why data should be protected. My own background is as a philosopher and a lawyer of privacy law. I've written several books about privacy and from a philosophical perspective and a legal one as well. And so I was really concerned about making sure that the legal requirements of protecting human beings' information about their health and their genetic conditions would be honored in whatever policies were made going forward.
Now, the Bioethics Commission found that only about half the states in the U.S. offered protections against surreptitious commercial testing. How has that changed since the Bioethics Commission issued its report?
Well, it's always been a concern that as DNA testing becomes less expensive, that basically all of the little bits and pieces that we leave of ourselves around the world, little flecks of dandruff or hair or saliva on a coffee cup, could mean that other people would have the ability to find out information about us. And so, since our report, there was an attempt in California to pass the Genetic Information Privacy Act. Didn't work, but the commentary on that law really did help to bring some of the issues to the public forefront. We hope that because the law in this area is state to state, that eventually there will come to be a consistent floor of privacy protections in all the states, so that one needn't worry as one goes about one's life and travels in the United States about whether or not one's data will be collected. I would say that most states do have some kind of law that makes it at least problematic to seek to have someone else's DNA tested without their consent, and I think that's been the case for a while. But what we really want to make sure of is that every state have a consistent floor, and that the laws reflect the latest in what's technologically possible as well as what's theoretically conceivable.
What impact has the Commission's work had on genetic research to date, and how do you expect the Commission's recommendations to guide future research?
Well, the Commission's recommendations regarding obtaining consent for genetic research and prohibiting unauthorized sequencing of genetic information was included in proposed changes to the U.S. Human Subjects Protections in 2015. The Commission's work was used to shape proposed revisions to these laws, and this is a very important contribution that I think we have been able to make. NIH has instituted a genetic information sharing policy that promoted the responsible sharing of genetic information in federally funded research. And we hope that the recommendations put forth in our report will continue to inspire and guide researchers, industry, and others who use or discuss genetic information, so that we'll have a more responsible handling of sensitive personal information, while also recognizing the tremendous benefits that can be gained from genetic research. As someone who spent a lot of time as a privacy advocate, I was a bit skeptical going into this project about the rush to engage in whole genome sequencing out of fear of the privacy consequences. But I came out of this project persuaded that there's so much public benefit to our participating voluntarily and with complete informed consent in whole genome sequencing and genetic research, that I really found myself taking a different point of view in the end. So I now agree that with again, informed consent and good practices in place, we're going to be able to take advantage of the technology without compromising people's genetic data.
Dr. Allen, it was a pleasure to have you with us today. Thanks.
And thank you for having me, Hillary.
You've been listening to Ethically Sound, a podcast of the Presidential Commission for the Study of Bioethical Issues. Thank you for joining us. You can check out our full series online at bioethics.gov.